Alright, question 26 to 28 in the ACER red paper. Question 26. Of the three isotypes of hydrogen, those that exhibit NMR are. Alright, so from the stem, we know that NMR is present where there is an odd mass number, or if there is an even mass number and an odd atomic number at the same time. If NMR is not present, then we know that the atom must have a even mass number and even atomic number. Alright, so as from before, the mass number is the number of protons and neutrons, and the atomic number is the number of protons. Alright, if you're unfamiliar with how to find the mass number, it is the number at the top left-hand corner of the atom. For example, 2H means that the mass number is 2, and from there we can say that the number of protons in this atom is 1 because it's hydrogen, and the number of neutrons must be 1 because 1 plus 1 is 2. Alrighty, so of the three isotypes of hydrogen, those that exhibit NMR are. So 2H does exhibit NMR because it is a atom with an even mass number and an odd atomic number. So basically, yeah, because the mass number is 2 and the atomic number is 1 because it's hydrogen. All right. So for 1H, or 1H, since it has an odd mass number, we therefore know it exhibits NMR. And 3H, well, 3H also has an odd mass number, so therefore it also exhibits NMR. So therefore, the correct answer for question 26 is D. That 1H, 2H, and 3H all exhibit NMR. Alright, question 27. In which one of the following lists does NMR occur in all of the nuclei? Alright, so pretty similar to just before, just got to work out the mass numbers and the atomic numbers. So, let's have a look at B. So, we know for NMR to occur, there has to be an odd mass number. So that immediately looks good for 3 helium, 19 fluorine, and 31 phosphorus, because they all have odd mass numbers. And if you know your periodic table well, you'll know that nitrogen has an atomic number of 7. So since it has a even mass number and odd atomic number, we can say that nitrogen also will exhibit NMR. So therefore, the correct answer is B. So you basically just do that for sort of all of the answers until you got the right one. And that's how you figure out question 27. Alright, question 28. The number of neutrons in the nucleus of an atom in which NMR occurs is always. So if I was in the exam, I'll have a quick look through the answers to see what sort of looks promising. A and B, well, they're incorrect because the number of neutrons can be either odd or even. That just depends on whether the number of protons is odd or even. So immediately we can rule out A or B. C, that the number of neutrons has to be odd if the number of protons is even to get NMR. Well, let's have a look through that. So if the number of protons is even, then the only way in which we can get NMR to be present is for there to be an odd mass number, because we can't take this pathway because that requires an odd atomic number. So if the number of protons is even, then we need an odd mass number. And the only way for us to get an odd mass number is for the number of neutrons to be odd, because if we have an even number, which is the number of protons we have, and we add that to an odd number, the number of neutrons that we're assuming we have, then we will always get an odd number at the end, which is the mass number. So an even plus an odd equals odd. So therefore, we can say that C is the correct answer, that the number of neutrons has to be odd if the number of protons is even. Now, why is question D incorrect? Question D is incorrect, not because the answer in itself is wrong, but because there is another possibility. It doesn't always have to occur this way. So if the number of protons is odd, from before, we know that one pathway for us to get an MR is for there to be an even mass number. Alright, and so if our number of protons is odd, and our number of neutrons is odd, then we'll get an even mass number, then we'll get an NMR present. The other scenario for this occur is the one listed in the answer is for the number of neutrons to be even, because if the number of neutrons is even and the number of protons is odd, we'll get an odd mass number, which also results in NMR. So D is incorrect because it is not the only way in which NMR can occur if the number of protons is odd. So question 8, C is the correct answer. And that concludes questions 26 to 28.